Okay, so I'm gonna ask you a question, and depending on time, we'll go on to the next one, and let's get started.
Okay.
So yeah, so first question I do want to ask is how longest consecutive sequence. Okay, I'm gonna write out the question. Gonna do this. Mhm. Okay, so if you see from line 1 to line 20, so given an unsorted array of integer nums, return the length of the longest consecutive element sequence. Okay, so for example, one we see that I purposely removed the output because I want to make sure you understand the question.
Yeah.
So do you mind going through the examples and letting me know what you think the answer is?
Yeah. So for me, when I'm looking at this, it makes me think that it's going to be the longest sequence where it's strictly increasing.
Okay.
So for example, 100 and 200. Well, 100 would be itself. 4 and 200 would be one, and then 1 and 3 would be another. So I guess 2 would be the longest.
Yes, deep. So just to elaborate, because given unsorted array of integer nums, we want to return the length of the longest consecutive element sequence, right? So example would be when we see 104, 200, 132, it is more so we see 1, 2, 3, 4. So that would be the longest consecutive elements for this input nums, for example, 1.
Oh, okay. So it's
Yeah,
1, 2, 3, 4 is here. Okay.
correct.
Oh, okay. And consecutive meaning it has to go up by 1.
Yes, correct.
Okay. And is that like a strict rule? So for example, what about 1, 1, 2? Would that be incorrect?
These will be all unique. Actually, it doesn't have to be unique. 1, 1, 2, 3, 4. That's fine.
Okay. Okay, got it. So I mean easy way to do it would be the sort. Right? That would be an easy way to go about it. I'm trying to think if there would be something simpler. I mean, something quicker than sorting. Like if we take multiple passes potentially.
Well, Michael, before we head into the solution, do you mind going through the example 1, 2, 3, providing your output answer? Just to make sure.
Yeah. So for this one, we see a 1, 3, 4.
Perfect.
Yeah. Like we discussed. Let me see here. So there's a 0, a 1, a 2, a 3, a 4, a 5, 6, 7, and 8. So that's 9. But I'm guessing that's the unique, so I wouldn't double count the 0, right? Okay.
Correct.
0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then for this last one, 0, 1, 2. Perfect. So it'd be 3. Perfect. Yeah, I just the length though, so the output would be like 4.
Okay. Very good catch. And before preface, I just want to let you know I've done about 40 plus interviews at Atlassian. So I do interview for senior engineer and staff level roles. So if you see some points where I'm a little bit vague, it's most likely on purpose, right? So the good catch from that, sometimes people just go through the question and they just return outputs and just keep coding, right? Sometimes they don't read the question properly, and then they miss the part where you have to return the left. Okay, good catch though.
Okay. So are you okay with me kind of thinking about the solution?
Perfect. Yes, I am.
Okay, like we said, sorting is easy, but I think if we if we use some space, we can come up with a way that's one pass. Like for example, let me use this one here.
Mm.
So let's say we had all of these in like a map
Mm-hmm.
where we have 100, 4, 2, and then we're going through one, right? We're looking at 100,
Yep.
and then we iterate through is 101 in map. If it is, we can increment our count, right? And then I think we do that for all of them. So we start at 4, right? Is it in map? Obviously, because we're looking at it 5, 6, and then we stop when it's not. And then we're at 1. We'll look at 1. We'll see there's a 2, there's a 3, and a 4. That'll give us that. I'm trying to think of potential edge cases here. Oh, I think if we don't want to double count, right? So like if we already, let's say we're already at 1, we've already know that 1, 2, 3, 4 is in the map. There's no need to double count that because the lowest number will yield the highest count anyways. So that makes me think that once we see something in the map, do we remove it or? That's something I'm going to need to think about. Let me start getting some code down for this, and then I'll try and trace what I have. Let me.
To put a pause there, why do you want to specifically use the hash map in this situation? Because I see you were talking about counts of well. Do you mind telling me a little bit more about your thought process behind that?
Yeah. So the thought process is like in the very simple way we can sort this, right? And we just kind of count.
Yeah.
And kind of like almost like a window, or I mean, even stood in a window, we just count until we're 1. So that would give us, like a n log n kind of complexity. So my next thought was like, how can we, is there a faster algorithm itself, or can we level space potentially to be better some way? So the hash map, it tells us like all the numbers we have. So it's kind of like a quick search essentially.
Yeah. Okay.
And since we know we need to go consecutive, we can just loop +1, +1, +1 until
Yeah, that sounds like your right direction. But I do feel like so let's just say you put the numbers in a hash map. Then what would you like to do with it?
so if these are in the map, right, then we're going to go through each one of these, and then kind of iterate. Can I show some code? I think that will.
Yeah, of course. Yeah, of course.
Let's see, August. How do you spell that word? Consecutive. Okay. Maybe it'll take. Wants to return that. So let's say. I mean, I don't know if it's worth doing this, but just in case. So now, create this hash map. We could just keep it a bool. Then we'll go through. I'll leave one of these. Okay. So now, what idea is we're going to go through this again. And now we'll start with counts. is equal to 1.
Mm-hmm.
I'll have like a max. Just say longest. And then we'll do 4. Oh, we could keep it 0. Just 4. 4 of n, pretty much.
Mm-hmm.
And just to be more explicit, we can do this. So now, like, what I want to do is I'm going to increment this count by 1 and the current number we're looking at by 1.
Mm-hmm.
And so, like, kind of like so. So that's kind of the idea I have right now. And then we'll okay. So that's kind of the thought right now. So, but now I want to kind of put this through some tests.
Okay.
Well, I guess this is something. I mean, in a typical interview, can I just write a test for this and run it?
Yeah.
Or
Usually in a typical interview, they have like quarterback, they have test cases. So I can provide you the cases just for the sake of time. I try to quickly go over.
yeah. I think it'd be worth it to kind of just trace my
Yeah.
thought process here. Okay, so let's say, let me paste this here just so I have a reference. So I'm going through 100. Count is 0. Say cur 0. It goes through one iteration of the loop. Cur. Let me call it iter. So this is in the map.
Yep.
So that results in count of 1, cur 101. And then that is not in the map. So we would break out it here. Longest would update to 1, which is correct. And then we would do the same for 4. It would travel to pretty much have the same result as 100 because there's nothing above it. 200 would be the same. I think the one that's interesting to me is if we started at 1. So count is now 1. Cur becomes 2. That is in the map as well. Count becomes 2. Cur becomes 3. That is in the map as well. Count is 3. Cur becomes 4. That is in the map as well. And then count is 4. Now, that's not in the map, and we'll break out and then set long as 4. So that makes sense. Now, if we were to go to 3, 3 would start pretty much here, and it would just do 3, 4, and then break out, and count would just be 2. Well, maybe we'll talk about. I guess what we could do is like if one optimization I could do is we can track our starting.
Yep. How would you track your starting in this case?
Well, we could kind of do that. Maybe I'm trying to think if we just start from the next one and then delete that from the map.
Mm.
that would I'm
Ha-
the
So, question for you. Let's just say we look at a number, correct? How do we know that this is the start of a sequence?
how do we know if that's the start of a sequence?
Yes.
Well, if that is a good question. If the number before it isn't in the map, we know it's the start of the sequence.
Perfect. And based on the information, I think you can definitely make the code a little bit more efficient.
Right. Let's keep this. Now let me see. If
Mhm.
maybe before we loop,
Mhm.
if track of n minus 1 continue. So if we're at 3, we won't even try. If we're at 2, we won't even. Yeah. Now the only I want to make sure that's correct because I don't want it to like accidentally remove a valid option. But I think it's fine because if, like, for example, if it was just 1 0, we know zeros in our map, so there's no like risk that we're gonna miss something above 1 if it isn't even there, because we would start at 0 anyways eventually. So that is, I think that's okay. As if I do something like this. Now the other question is a duplicate, like if we've already, but maybe that's, we don't want to double count that. I mean, maybe, I don't know if it's worth it to keep, maybe after we're done, we could just remove it. But I don't know if that's an optimization. Like, let's say there was another 1 here. If we were to remove 1 from the map, by the time it got to it, it wouldn't even go here.
Yeah.
And that would be fine. Let me get some space here. Okay, that's the last thing I'm thinking now is, do we want one more thing to remove a duplicate count? I think it'll be safe if we were to do that.
So you know how you said that you're worried about duplicates, correct?
Yeah.
There's two ways to go about this, and any way can work. Right. So with this duplicate, so hash math is looking good, but maybe instead of iterating through your list, the input list, maybe you can iterate through the hash map. That can also be an idea. So therefore, you're iterating instead of iterating to the list where there's duplicate. When you Yeah, so that's a possible way. And then so this is the second way I want to challenge you on, right? So the first way, yes, it works, but it may not be the cleanest, right? What is something else we can use to kind of just make our lives easier? There's similar method, right? Something with along the lines of duplicates. There's another thing we can use that can make our lives way easier.
So, like you said, one option is just, instead of iterating through the list, we just iterate through our hash map and then do the same thing here. Um, and then that would kind of remove the duplicate problem, and we can still do this as well, the previous element.
Yep.
But you're saying there's another thing I can do as well.
Yes. Yes. So I'll give you like maybe like few seconds to figure it out. If not, we can it's okay. Your first path works as well. So we can go with that. Is there anything we can use?
Let me modify this to use the map, and then I'll
Yeah. That sounds good.
and see if it comes to me. And then essentially the same. Okay. Let me just double check. For previous ones there, we can skip this one. Then we start it and we iterate, and then we track the longest we've seen. And then we know we won't deal with duplicates because we're iterating through the map itself. Yeah, and I'm a little stuck on the hint you were trying to give me on
Yeah, it's
further.
not a big issue, but let's go with the hash map solution. Let's go with this one, and then I'll tell you at the end like how we can make it a little better. I think this is good enough though. So
Okay.
let's try uh any details and try running it, and then we can go from there.
Okay. Oh, you already put it here. Okay.
Yes. Mhm.
Oh, is this it at the side? 493. Okay.
Alright. Do you see that? Do you see the execution on the right side?
Yeah, I think it's on the right. Right. There's
Yeah.
493. Yeah. Okay. Yeah.
Okay.
Cool.
Perfect. It looks good. Now, what would be the time complexity for a solution?
So time complexity would just be 2n or just n,
Perfect.
one big O of n, and then a space would
Mhm.
space of the n because we're tracking.
Perfect.
Yeah.
Sounds great. Sounds great. So yes. So quick feedback. So you did well. First question. I think because I know for staff or seniors, they're always looking for the most cleanest, efficient solution, even if it works. So something sometimes people are nitpicky about is maybe instead of using the hash map, right, you can use a hash set, right? You can use the hash set and just iterate through hash set. So therefore, you don't have to keep track of like the keys and values, where you can just create a hash set based on the input that you received. That's one thing, like a minor efficiency. And then number two is maybe instead of doing if track n minus one, you can do like a something like this. Let's see, along line 57. All right, you can kind of just remove that and just put like this, just for like syntax wise.
I
So you have how it goes. But your other solution does work, so I think it's good. I'm just gonna put it back. Just in terms of like syntax wise, like specific coding paths, they want you to be a little bit more specific. But other than that, this question was good. Any questions for this one?
No, I think it makes sense.
Okay.
I guess one on your comment on the hash set.
Yes.
Go doesn't have a set.
Oh, okay. Perfect. Perfect. Okay. The hash map should be the best solution. Perfect. Perfect. Now, anything else before we move on to the next question?
No, that makes sense. Thank you.
Perfect. All right. Sounds good. Sounds good. Okay. Second question. I'm gonna remove this. Don't mind me. Maybe I'll just roll up. Okay. Okay. Are you familiar with trees?
I'll give it my best shot. Yeah.
Okay, perfect. Don't worry. So I'm gonna copy and paste this question and we can go through it. Okay. Okay, so given a binary tree root, return the level order traversal of it as a nested list where each sublist contains the values of nodes at a particular level in the tree from left to right. Okay, so you see in example 1, we have the tree, right? 1 is the root node, 2 is the left child node of 1, 3 is the right child node of 1, and then 4, 5 are the child nodes of 2, 6 and 7 are the child nodes of 3. So based on this, do you mind going through the examples and the corresponding answers?
Sure. I don't see any trees, for example.
Line 5 to 7. Line 5 to 7.
Oh,
Well, yeah, so this first row of 5, 1 is like a child node, and then line 6 is 2 and 3 child nodes of 1.
right. Okay. And what was your question again?
Oh, do you mind going through each example and making sure that you understand the output?
Oh, yeah. Okay. So, level order traversal, um, pretty much is kind of like you just go through the level. So root is going to be by itself. We pretty much go through the rows. If you could think of it as rows from left to right,
Yeah.
will be each level. So 1 will be its own, and then from left to right, it's 2 and 3 in its own list,
Mm-hmm.
and then 4 through 7 would be its own list.
Mm-hmm. Yep. Perfect. Yep. Very straightforward. Now, how would you approach the solution?
Yeah, so the way I'm thinking about it is the way it's kind of speaking about levels makes me think of like a BFS type solution in which I'm using a queue.
Yeah.
But I think the trick is going to be that I need a cap. Like when I'm iterating through the items in the queue, I need to cap it by the length first. So I make sure I'm only adding that level
Mm-hmm.
to the answer, or else I would have to come up with my own struct that keeps track of level, and I don't think that would be worth it.
Mm-hmm.
So that's kind of how I'm thinking about it. So I'll start at the root. That's going to be in the queue, and it'll be the only one in that level. So I'll add that as a list. I'll have to be building an array during my inner loop, and then I'll add left if there's a left. If I'll add right if there's a right, and then that type of thing. And then I'll just repeat that process until the queue is empty, and then I'll keep adding that that closed list to the main result. That's what I'm thinking.
Yep. It sounds like the right direction.
Okay. Let's give it a go. And it'll take. Should I assume I have a struct, or should I assume it? Yeah. Okay.
Struct is fine.
Okay. I'll just say.
Perfect.
So let's do that, and then this will be a list of the values. That's what it looks like. So easy case, if the root is nil, if they're nothing. And now what we can do is, let me fill up the result array, and also the queue, which will be a queue of nodes. And I can initialize it from the start. or make sure that looks fine. E. Okay. And now what I'm gonna do here is I want to set up a current. Why does it keep trying to correct that for me?
Mhm.
Okay, so I want to set up a current list that I'm looking at, which will be, I get to be more explicit, you call it level, and then we'll say n is the length of this queue. Out this level, essentially. Um, so let me call this something else. Pause. That way I can use n as this one. Okay, so I'm gonna get the first thing in the queue and then get rid of it. Makes sense. And then all I have to do is add it, I believe, to our current level. After we've added it, so let's say if this was the root, we would have a 1, and null. And then what we would need to do, there's still a couple more, 3 things I need to do. Let me just add this. Once we're done iterating through a level, we add, I'll change that to level. Okay. Now, if n.left doesn't equal nil, we can add it to the queue as well. If n.right doesn't equal nil, we can add it to the queue left. All right. So the root is nil. We don't need to return anything. We set up the result list. We start off looking at the root. Get the size so we can cap how big our level is. And then, if this was the root, n would be root, level would be 1. We would add, what was it? 2 and 3 to the list. 2 would go first, and then 3. And then since this is just 1, we would break out, and then we would have 1. And then next iteration, this size would be 2 for 2 and 3. And this is 2, we would add 2 to the level. We would add 4, I believe it was 4 and 5. And then we would go to 3. 3 would add to the current level, and we would add 5 and 6, and then so on. So I think that makes sense. Oh, here, let me fix this here up top. This be below target. There you go. Okay. Yeah. Well, okay. That makes sense.
Perfect. Okay, I'm gonna provide hover function just to create the tree so we can start testing it. Okay. Let me just turn everything to tree.
The level order traversal.
Okay, I put some skeletal function. Let's see if there's any issues. So you have some node. We have some differences. You have your node class as left and right. Okay.
So I did lower cap. Lowercase.
Okay. Let me just. I can just change it real quick. Okay. And then no. Okay. And then any other issues? Give me 1 second. See. Okay. Do you mind reviewing? Because based on the build, so I created a build tree. Let me just fix it for you. Okay. For sake of time, should be good. No. Yeah. Let me just fix this up real quick. Yeah.
Bug.
Perfect. Let me just change it. Okay, for a second time, let me just go through the pseudocode. So everything looks good in case. Let me see. What will be the time and space complexity for the solution?
So space. I mean, we're not. I mean, we're not really holding anything extra. Besides using the queue, but I mean, I guess you can think of the queue. The queue will only hold the at most like a amount of level, like the nodes in a level.
Yep.
I don't know what we would call that. Maybe like I don't know if there's a formal term for that. K, I don't know. But in terms of the time, we're pretty much the time complexity is just the height of the tree, essentially.
Perfect.
We're only through at most we're going through. Well, we're going through like if you think of it as like a stairs or elevator, we're just going through the height.
Why would you say height of the tree for this one?
Oh well, we're touching every node, but so I guess we can't, and we're not cutting off any time. Okay, so actually, the time complexity will just be O of n because we have to touch every node.
Every long. Then what is the space complexity?
This is where I'm a little iffy on because I'm not sure if Q counts as at the base. I mean, technically, it would, because we're creating something in memory is the Q. But the space complexity would pretty much be the biggest number of nodes in a level, which I guess you could think of that as a constant.
Sorry, Fan, what's your solution?
My hunch is it would be a constant space.
Okay. So you said are you saying all of one for this one?
That would be my hunch, just because the number of the queue will only have a level worth of nodes. I mean it's not free, so I could see the argument where it's not O of 1. I just don't know if there's a formal term for O of the the most nodes that a level has, and the whoever has is the nodes in the level.
I
Would
see.
be energy.
Yeah. So we was saying for this one, we would say all the way n because when we say storage, right, we want to put in every node in storage.
Oh yeah, that makes sense.
Yeah.
Okay.
I know what you're saying, right? You're thinking like it would be the O of what the biggest level is, correct? Like the last level, because you think that's a container, but that's not how it works in space complexity. It's more of how much space are you allocating in general. So you were in the right direction. So it'll be O of n. Okay. So I also fixed the helper function. So do you mind running the code for this one?
Yes.
Okay, let me see. Okay, perfect. One second. Let's see. So I had this example is okay. Okay. Yes, perfect. Got it. Let me just make So for this everything looks good. Yeah. 3, 9, 20, 5, 7, 1. Perfect. All right. So you're able to do the solution. So we have 13 minutes left. So what I could do, up to you, because I think so just some small feedback, and then based on the how you like the feedback, we can go off on that. Maybe you can challenge yourself a little bit more. So for the first two questions, it seems like you were in the right direction, right? So I think in terms of like staff senior, you should be good. Just little nitpicky things of I saw in the very first solution how you were going in an efficient route. You caught yourself, and you're like, how can I make this more efficient? So that's a great catch. And just knowing how okay you understood what is the lowest, how do you find the first number of achievements, and once you're able to find that, you definitely made a solution from O of n squared to O of n. That was great. This solution as well, you already knew off the bat you needed to BFS. It seems like all your syntax, everything is good to go, right? So based on this, do you want to give you, I can give you an even harder question right now, and then you just give me the pseudocode of it. Like, you can just talk to me how you would approach it, and we can go from there. Would you like that approach? Because it seems like the first two questions you understood a little bit. I think you may need a more challenging question.
Sure. Yeah.
Okay, perfect. So for the sake of time, I'm gonna copy and paste the question, and then I want you to kind of just walk it down with me. Like, just tell me what you would do, what you would code out, what type of approach you would do, and then without even coding, I want you to tell me the time and space complexity. All right, just sometimes people do ask that. Okay. Okay, here is okay. All right. So interview prompt. So this is cut trees on a cliff. It does not exist anywhere. I made this question myself, and usually just for the sake of time, I put in the prompt. What I would do is I'll give you like a very, very big prompt. And then what I tell the interviewee is to make the question for me to even make it more complicated. But just for the sake of time, I provide the question. So you are a landscape designer working on a vertical cliff covered with trees. Okay. The cliff is modeled as a 2D grid. So let's just say there's a matrix you're given. The ones are part of the tree, zero is like empty space, empty rock. Okay. The bottom row is top of ground. Two trees are connectable if they are adjacent, up, down, left, or right, or directional. A tree is considered stable if it's connected to other trees. There are at least one tree in the bottom row. And if the tree is not connected to any tree in the bottom row, it will fall off the cliff and disappear. You're given an n times n grid, landscape with 0, 1, a coordinate cut of RC, right, which is a row and a column, representing the tree you cut down. Cutting this tree means the cell R, C becomes 0 first. After that, any trees that are no longer stable and no past the one to the bottom row will also fall and become 0. Return the resulting grid after all the unstable rows have fallen. So I'll provide you an input, and I want you to kind of tell me what you did. Okay. So this is the example. Okay. And what I want you to do is, what would the output be? Okay. Yeah, this is just an example. Yes. So, any questions about this question?
I think it makes sense. So I pretty much need to find
Uh-huh.
the unstable trees and then flip them to 0,
Mm-hmm.
right?
Correct. Yes.
Okay. Okay. Well, wait. I have a hunch on how to go about this.
Okay. What do you think the output would be in line 37? I think we can start with that. All right. So landscape is so right now. You want to say landscape is this one. The cutting the coordinate. Okay, let me provide that. Cut the cut coordinate is going to be 1,3. So how would the tree look like after we cut 1,3?
Oh, okay. So you cut that first and then
Yes. Correct.
you go about the problem? Okay, okay.
Yeah. Mm-hmm.
1,3. Let me do this here. So this.
Yep. You cut that. Roll it out.
Okay. Okay. So the way I would think about doing this is we know that a tree has to start at the bottom. So what I would do is I would go through the bottom and I would look for any tree at the bottom.
Mhm.
Once I see a tree at the bottom, the I would do like a DFS to find all the wires connected to it. So this could be connected, this would be connected, this would be connected, this connected, this connected. Um, and that's it. So this would be a 0, this would be a 0, and that would be a 0.
Perfect.
So that's
Yeah. Okay. Yes. Or one more example, and we can go on with your pseudo code. So let's just say example 2. Let's see. Let's try and make this a little complicated. Okay. Okay. And let's just say the cut coordinate is also to this. Yes. So what would be the alpha phi for this one?
So cut is 1, 0, 1, 2, 3. And that comes to 0 to start. So essentially the same. So I would look through these. So this would be good. This is good. This is good. This is good. And also that's kind of, I feel like this is all connected. I can't like to connected, and then we would go here. I feel like this would be it, in my opinion.
Yeah. Exactly. Yes. Okay. Do you mind providing like a pseudo code? Like you talk to me through it. I know you give me a little bit of the details, right? Like a pseudo code skeleton. It doesn't have to be like exact. We're not gonna run it. Just like pseudo code Golang code.
Sure. So, and let's say we're modifying the grid in place. So first off, I'm just going to assume correct input. Well, and that to say cut. Well, I mean, it doesn't matter if it's a stack or. So I think to traverse the point. So we'll do that as a point, and then And then I also want to keep track of like the length of the grid, assuming the input is fine. So now here, what I could do is, oh no, not necessarily like this. And hold on, I need to look from the bottom. So it would be for, let's call it J, if that's small, means grid of M minus 1 is what it would be. And then if grid of M minus 1 J is equal to 1, well, I guess we could, if it's not equal to 1, we just continue. If it is equal to 1, what would be a good thing to do? I'm trying to think if we would need like something like a map to know what we've seen.
Yeah, that's good. Like a visited map, correct?
Right. Something like that. Just so we know while we're doing this traversal, whether we've seen it or not. Okay, something like that. And then I would mark it. We'll say the point is, it will be M minus 1J. And then seeing point equals true. And then I don't need to do this here, right? Because I could do this like this, and then it would be, oh, we did P. Okay. So it kind of look like that. And then essentially what I'm trying to think, like maybe we mark them because at the end of the whole thing, I need to mark what hasn't been touched. But maybe I could just use the scene map instead of malting them as like 2 and then having to flip it back to a 1 or something, you know? I think that would be fun, actually.
Yep.
Okay. So something like this. And then the points will be stack of that, and then I would get rid of it. And then the neighbors would be let me we'll call this tail so I can use iron there. So ij p0 p1. So I plus 1j, I minus 1j, I j plus 1, must be minus 1. Oops. So go through each neighbor. If it's out of bounds, then we can ignore it. Or if we've seen it, we can ignore it. Or if it's not a 1, we can ignore it. Otherwise, we can mark it as seen and then add it to the list. Is that it? And then finally, like at the end of all these bills, you can go through the entire grid. if, and then they, if we haven't seen this point, then my thought on the whole
Mhm.
thing.
Yeah.
I
Um,
know but sometimes me writing code is easier for me to think about.
Of course, of course. Yeah, so I think so everything's going the right direction. I think it's pretty solid. I saw because I was waiting for you to make sure you checked the scene, which you did at the very end. So that's very good. And what would you say the time and space complexity for this?
So it would be if M is the number of rows and N columns, we have to go through essentially everything. So M times N,
Mhm.
and that's for both.
Sorry, you cut off a little bit. Sorry, say again? What?
Yeah. So for M times N for both time and space.
Perfect. Okay. Sounds fair. Okay. Yeah, done. Hey, I think everything's pretty solid. But in the next within the next 5 minutes, I'll provide some feedback. But don't worry, everything will be more in depth in the feedback I'll give you in the written. And if you can also provide some feedback at the end for me, that would be great. So also, just to preface, for that first question, I apologize for pushing that hashed direction. I just been working so much with JavaScript, Python, and Java. So for Golang, I completely forgot about that part. So I apologize on that behalf.
No worries. It's all good.
Okay, got it. So in terms of feedback, so let me say for second question you did perfect on, right? I guess the only issue was that space complexity, right? Yeah. The space complexity, so brush them on that, time complexity looks fine. Everything looks good. First question, although it was easier than the second question, I think there was so I know you stated that you like coding and figuring out through that path, but sometimes interviewers, depending on what type of interview you had, they might not like that. They might want you to kind of verbalize what path you're going in and then start coding it up, because sometimes they can see it in a way where, I'm not sure which way I'm going to go, so I'm just going to start coding things hoping something can stick, right? So try to have a sense of concept before going in. And even if you're stuck in the sense of concept, ask the interviewer, like, hey, like, this is my logic. Do you think, am I going the right direction? Is there anything that you would like I should change? Right. So it's like you're kind of asking the interview, putting the interview on the spot, like, hey, like, looks good. Confirmation, yes. Okay, perfect. I'm gonna start coding it up. So maybe try doing that. Although I know that, like, try getting the habit of that. All right. So first question, and then I think you got a little. Here's a very small hiccup. I think I was trying to push you to understand, like, how do you know this is the first number of the sequence, right?
Yeah.
I mean, you might have gotten it maybe like a minute or two later, but I just wanted to kind of push you just to say, like, try to use all the data as leverage, right? Because that was a great cache you had where you stated, huh, I can just sort it, but it'll be n log n, but I want to make it a more efficient solution, right? So it's not going to be sorted. Whenever you think of sequences, you gotta think, oh, okay, what's the first number of this sequence? That's the pattern that you should try to like pick up on. Okay. For this question, I think everything was great. You had, like, just for the sake of time, but you were able to understand the question very quickly. You were able to get the example 1, example 2 output. Even when you were doing studio code, I mean, everything looks pretty solid for the most part. So yes, that is my TLDR feedback is brush them on space complexity to try to get a solid, like, variable solution out and then start coding it in. I think that would more preferred. Trying to talk more about how you would approach it rather than just dive into the code.
Okay.
Yeah. So you have any small feedback for me besides, I know, me suggesting hash that part?
I mean, honestly, this like kind of being my first one, and I thought it was great. And I appreciated you not giving me too many hints. Only like when I really needed it. That was helpful. Um, you also weren't completely silent, which was nice. And
But I do have to give you a heads up. There are interviewers who will just let you struggle. So I'm more of like for me, I want the best for people, right? And if you know how to code, if you know how to understand the solutions, like, on the job, you'll be just fine, right? But I know there are interviewers out there who are just completely silent, and when you're stuck, they won't say anything, right? So some advice as well is, let's hypothetically you get an interview who's completely quiet, very silent, okay, and you're talking out your solution. Anytime you ever get stuck or you need some type of verbal communications, tell them, hey, this is what I've done. What do you think? Right? Because I always like interviews to be a casual conversation between two engineers trying to figure out a complex problem, right? So tell them, hey, what do you think about this? Am I going in the right direction? Put them on the spot. So there's always a feedback loop. So you don't know if you're in the right direction or not. So, right? So that's the number one tip I would always provide.
Okay. Sounds good.
And I think that is basically it. And then I think other tips. So since you have, and you said you're gonna start applying to interviews, so that's good. If I can provide a little bit more advice, is that this Christmas coming up, right? I think you should start applying now, right? Maybe apply to companies that you may not be too happy about, but more like for practice. Start doing that now. And then maybe a week later, then start applying to like the higher companies that you do want to get to, get the referrals, start filling them in, because when Christmas comes, everything's going to be on pause, right? A lot of people are going to go lose the space in. So let the applications sit. And I think by first week of January, second week of January, that's when all your interviews are going to start piling up, right? And then hopefully like you have already like first round interviews or second round interviews by like the first or second week of companies that you're not too crazy about. And by the end of January, that's when you're like, okay, I'm very like set. I'm doing good. I'm gonna do the companies that you do care about, and hopefully you do kind of finalize something by mid-February, like by average time. Mid-February to end of February, you should be able to secure something. Because based on your technical expertise, your communication, everything is looking pretty solid.
Okay, that's good to know. I had one
Yeah.
question for you.
Yeah.
I was curious about getting one of the coaching packages.
Okay.
For like this for the
Yeah.
staff level. Do you find that to be worth it? Or, and also another question is like, if like my top company isn't necessarily a FAANG company, like it's Enduro, I don't know if you get with them. How do you know which one to choose, which pack?
Okay, sure. So the first question we said, is a package worth it? I started the interviewing.io. I started interviewing them a few weeks ago, but I know a few people who are actual coaches for that program.
Okay.
And if you read briefly, I think the success rate is like 99%, right?
Yeah.
So, and there's also a policy where if you're not happy with it, you can get let me just double check this. Don't quote me on this, but based on what I saw last time, if you're not happy with it, you can get a refund.
Yeah, I read the.
Yeah. Yes. Right. So I personally would say it's worth it, just because based on the statistics and data, and the mentor that I know, he worked as a Airbnb staff engineer. He also worked as a senior engineer at Meta. So if you're interested, but I think he works on the Meta or Airbnb route. So if you want to get in touch with him, I can refer you to him. But TLDR, yes, I would say it's worth it. It is a little pricey, but once again, if you're not happy with it, it's not looking so good, you can get a refund. And two, based on the data, it is a very successful rate.
Yeah.
And then second question, you said that if you, let's just say one of the companies that you really like is not considered a FAANG company, you said which package should you do? Yeah. That is a good question. I will redirect that to, I think, a lean learner. I think, if you don't mind me asking, which company are you trying to get into?
Yeah, their name is Enduro. They're based off of.
Okay. Got it. I can ask Aline, say that, hey, is there any packages for Enduro or is something similar to it? Because I know for the company specific packages, they're very, very specific. Right. So I don't want you to spend money on something that's not in the same path as Enduro. So if feel comfortable, if you do want to share your contact, feel free to just add interview. If you don't feel comfortable, I think reach out to whoever got you interviewed, interviewing.io.com or a lean learner. I think if you just ask some questions, they will be able to answer further.
Okay, cool. Yeah, well, I'll do that. And I feel like I remember seeing like you can chat with someone for like 10 minutes to discuss what's
cohesion. Yes, 10-15 minutes you can chat with a current mentor or coach.
Okay, cool.
Perfect. Any other questions?
No, that's it. Thank you. I appreciate it.
Perfect. Thank you so much. Thank you so much, Michael. Have a great day, man.
You too.
All right,
Yeah.
bye.